Good day, everyone. Today we'll be looking at a topic that says that integration of algebra function theory trigonometric substitution method one. Yeah. Previously we worked on the how to integrate algebra function or integral that using a substitution method. But there are some algebraic function that will be given or integral that will be given that you cannot apply direct substitution method to it. So that is why we'll be working on this topic today, because the topic telling you how to solve some algebra function on integral that actually we are going to apply trigonometric substitution method, but still you are going to apply the same method, but it's form of what? It's form of trigonometry substitution method. So it's of three formats actually. The first format today is when you are given some integral in form of that you have in this kind of sample given, like the first one. If you are given in integral of square root of a square minus s squared dx, and maybe it's in form of quotient, shows that it is an integral of 1 over the square root of a square minus a square. This kind of integral that cannot be solved directly using direct substitution method. We have some integral question that you can solve directly without using substitution method, and I taught you in the previous class that how to solve integral question that by using a substitution method. I gave you the format when you can say, okay, I'm going to use substitution method here. So but this one you are still going to use substitution method, but firstly you need to make use of trigonometry substitution method. So if you are given an integral question in form of these two formats here, so that integral of square root of a square minus s squared dx, and integral of quotient function of 1 over square root of a square minus s squared. So how can you do this? Once you see this just format, you do what? It's just only for these two formats. You do what? You let x to be what? A sine theta, in which you can get your a. Your a is equal to your a. You compare the coefficient, and you have better understanding of this when we are treating some examples regarding this subtopic. So let's go into example. So the main thing is the first step is replace x with a sine theta, and what will be your a? It will be shown to you in the next in the following example. So this example state that evaluate the integral of square root of what? 1 minus s squared. So comparing the question given with the standard format of the integral, that is integral of square root of a square minus s squared dx, thus we can say that what? Thus at the step one, if you do the comparison now, so if you do the comparison, you will see that here, so the step one is what make you will see that x is equal to a sine theta, in which our a is what? Is 1. So that is why you see that x is being written as is actually equal to what? Sine theta. You call that a is equal to, like I said earlier. So then the second step, you differentiate x with respect to theta. So differentiating, that's why we are getting at the beneath that what? The x, the theta equals cos theta, which implies that the x is equal to what? Cos theta the theta. So step 3 says substitute everything relating to x with theta. So if you do that, so everything that has relationship with x, you are going to replace with theta. So that is the meaning. That is step 3. So you go back to the initial question given, which is integral of square root of 1 minus s squared. So that's why we see that the next line beneath the step 3 is what? Is being changed from what? From the initial question to what? Integral of square root of 1 minus what? Sine squared theta parenthesis multiplied by what? Cos theta d theta. So you will be, imagine that how do we derive at cos theta d theta? You recall that the x is equal to what? It's equal to cos theta d theta. And you were told earlier that what? You must replace everything relating to x with what? With theta. So that's why everything is being changed to what? To theta. So recall that 1 minus sine square theta, that is another line, equals what? Cos square theta. So that is standard, from trigonometry. And go back to the topic and learn more. So to know how we derive at this. So the integral of square root of, so you can see that the integral of square root of 1 minus sine square theta eventually change to what? Integral of square root of cos square theta multiplied by cos theta d theta. Because 1 minus sine square theta is what? It's cos square theta. So that is why we are changing square root of 1 minus sine square theta to what? Square root of cos square theta. So now after that, square root of cos square theta is what? It's cos theta. So that's why in the one at the front of that line, you can see that integral of cos theta is multiplying cos theta d theta now. So in the next line we have integral of cos 2 theta d theta. So also recall that cos square theta is what? That is also from compound angle inside trigonometry topic. Yeah, and verse 1 actually. So you can see that 1 plus cos 2 theta over 2 equals what? Cos square theta. Thus, the integral of, you substitute cos square theta with that value now. That is 1 plus cos 2 theta over 2. Because you cannot differentiate cos 2 theta directly like that. It will be difficult. So, you need to find a way of making work easier for ourselves. So you get it now. So that was why we thought of what can we replace cos square theta with. So, and we arrive at 1 plus cos 2 theta over 2. It's standard, it's basic. So that will now lead us to what? Integral of 1 plus cos 2 theta over 2 d theta. Over 2 what? Over 2 d theta, which implies that what? So you can see that in the next line we change we bring out what? We bring out the 1 over 2 from the value that is inside the integral. So that's why you are saying what? 1 over 2 integral 1 plus cos 2 theta d theta. Shall you get it now? So which eventually implies that 1 over 2 open brace. So now we are now going to direct. We are now applying the normal method for integration, because that d theta will be multiplying everything inside that bracket. So that is why we are now having in the next line that 1 over 2 open brace integral of d theta plus what? Integral cos 2 theta d theta. And you can see that in the next line we have 1 over 2 open brace theta plus integral cos 2 theta d theta. We can actually differentiate the theta from the first video of this YouTube channel. I showed you how integration formula. So applying direct integration formula, you're supposed to be able to know by now that integration of the theta will eventually give you what? Theta. So that was why we're having in that line that what? 1 over 2 open brace theta plus integral of cos 2 theta d theta. So via substitution. So now that integral of cos 2 theta d theta cannot be solved ordinarily like that. So you need to apply substitution method. So not trigonometric substitution method this time around. It's just ordinary substitution method. So via substitution, not ordinary actually, but substitution method. So via substitution, you change you take u as 2 theta. That is 2 theta is being used as what? As u. So you differentiate with respect to theta now. So the theta is equal to what? It's equal to 2. So which means the u is equal to what? 2 d theta. So now you replace the theta with the u over 2. So that's why you see that the next line is changing to what? It's changing to 1 over 2 open brace theta plus integral cos u du over 2 close brace. So the next line is that what? 1 over 2 theta plus 1 over 2. Actually, you can integrate cos u du directly, because it's just ordinary number, not function on function this time around, based on that expression. So that was why you can see that it implies as 1 over 2 open brace theta plus 1 over 2 sin u close brace plus c, because the integration of cos u is actually what is sin u. So, and you can see that 1 over 2, now you can observe that we've changed everything from u back to what, to the theta, and eventually we are still going to change theta to what, to hex, because the initial question given is on hex. Shall you get now? So 1 over 2 open brace theta plus 1 over 2 sin 2 theta close brace plus c. So recall that x equals what, sin t theta, which implies that theta is equal to what, arc sin x. So also sin 2 theta equals 2 sin theta cos theta. So which means cos theta equals what, square root of 1 minus, recall I've made mention of that earlier, cos theta is equal to what, square root of 1 minus sin square t theta, which implies that cos theta is equal to what, now replacing sin square t theta, because that x is equal to what, x is equal to sin theta. So that is why cos theta is now eventually changing to what, square root of 1 minus s square. Check again now, s square, because s square is now what, sin square theta. So which means sin 2 theta is equal to what, 2x square root of what, 1 minus s square. Recall that your 2x is now what, your x is actually what, is sin theta, and recall that sin 2 theta is what, 2 sin theta cos theta. So that's why you're having 2x square root of 1 minus s square. So you now substitute everything back to the initial question. So that is why you see 1 over 2 open brace theta plus 1 over 2 sin 2 theta close brace plus c implies that what, implies that 1 over 2 open brace sin arc sin x plus 1 over 2 parenthesis 2x square root of 1 minus s square close brace plus c. So, and we have what, we have 1 over 2 parenthesis arc sin x plus x square root of 1 minus s square plus c. You can see that because 1 over 2 will be cancelling out 2x, remain x. That is why we're having x square root of 1 minus s square plus c. So, and our final answer is what? Is 1 over 2 arc sin x plus 1 over 2x square root of 1 minus s square plus c. So which means the integration of square root of 1 minus s square dx is now what? Is now equals to 1 over 2 arc sin x plus what? 1 over 2x arc sin 1 minus, which means the integral of square root of 1 minus s square dx is equal to 1 over 2 arc sin s plus 1 over 2s square root of 1 minus s square plus c. So that is the answer for that one. So the second example say that evaluate is just same procedure. So you can see that here the question given is integral of square root of 60 minus s squared dx. So if comparing the data given now, if integral of square root of 60 minus s squared dx implies that integral of square root of a square minus s squared dx. Now making comparison now, you can then conclude that a square equals 16, which implies that a is equal to what? A is equal to 4. Find the square root of 16 is 4, which means a is equal to 4. So following the normal step, so step 1 say let x equal to what? 4 sin theta. So step 2, you differentiate x with respect to theta. So dx the theta is equal to what? 4 cos theta. So making dx the subject of the formula, dx is equal to what? 4 cos theta the theta. So step 3 is substitution. Then you substitute everything relating to x with what? With theta. So you can see that the integral of square root of 16 minus s squared dx is now what? Integral of square root of 16 minus parenthesis 4 sin theta all square multiplied by 4 cos theta d theta. So we have integral of square root of 16 minus 16 so we have integral of square root of 16 minus 16 sin square theta multiplied by 4 cos theta d theta. So which eventually give us what? Square root of 4 parentheses, which eventually give us integral of 4 parentheses square root of 1 minus sin square theta multiplied by 4 cos theta d theta. Recall that cos theta, like I said earlier, is what? Is equal to square root of 1 minus sin square theta. So you replace cos theta with what? Square root of 1 minus sin square theta. So which means integral of 4 cos theta multiplied by 4 cos theta d theta. We eventually have integral of 16 cos square theta d theta. So we bring that the constant, which is 16. So that is why you're having 16 outside there. So 16 integral of cos square theta d theta. So recall that cos square theta, like we did earlier, is what? 1 plus cos 2 theta over 2. Then you substitute cos 2 theta with what? 1 plus cos 2 theta over 2. So that is why you see the expression for 16 integral cos 2 cos square theta d theta implies that was 16 integral of 1 plus cos 2 theta over 2 d theta. So 16 over 2. You can see we're having 16 over 2. Why? Because the 2 at the denominator will be taken out, which is constant. That is 1 over 2. So 16 over 2 integral of 1 plus cos 2 theta d theta will eventually give us 8 integral parenthesis 1 plus cos 2 theta d theta. So now you just apply normal integration method. So we have a brace integral of the theta plus integral of cos 2 theta d theta, close brace. So we have 8 integral of theta plus integral of cos 2 theta d theta, in which we've been taught earlier how to integrate function like that, which is because it's a function of a function. So you apply substitution method whenever you come across function of a function. You must know that a substitution method, actually you don't need to stress yourself or think much. So we are substituting u as 2 theta, that is u is equal to 2 theta, thus the u is equal to 2 d theta, which implies that du over 2 is equal to d theta. Thus 8 open brace theta plus integral cos u multiplied by du over 2. You know, we've applied substitution like that with substitution method. So which implies that 8 open brace theta plus 1 over 2, we've taken out the constant 1 over 2 integral of cos u du, which eventually gives us 8 parentheses theta plus 1 over 2 sin u plus c. So recall that u is equal to 2 theta. So you return everything back to what? The one with u, return it with theta. So that's why the expression is now changing to what? 8 theta plus 4 sin 2 theta plus c. I also recall that because once we must return everything back to x, so recall that x is equal to what? 4 sin theta, which implies that theta is equal to arc sine parenthesis x over 4. So sin theta is equal to what? X over 4. So also sin 2 theta is equal to what? 2 sin theta cos theta. And recall that cos theta is equal to square root of what? 1 minus sin square theta, which implies that cos theta is equal to what? Square root of 1 minus parenthesis s over 4 all square. So all square. So sin theta is now equal to what? 2 multiplied by x over 4 parenthesis square root of 1 minus parenthesis x over 4 square. So which implies that what? X over 2 square root of parenthesis 1 minus x over 4 all square. So therefore 8 theta plus 4 sin 2 theta plus c equals to what? Equals to 8 arc sine x over 4 plus 4 parenthesis s over 2 parenthesis square root of 1 minus parenthesis s over 4 all square plus c. So x is, which eventually equals 8 arc sine x over 4 plus 2x parenthesis square root of parenthesis 1 minus s squared over 16 plus c. So solving the fraction, we have 8 arc sine x over 4 plus 2s square root of 16 minus s squared over 16 plus c. So in which we have what? 8 arc sine x over 4 plus 2x multiplied by 1 over 4 square root of 16 minus s squared plus c. So and the final answer is now what? 8 arc sine x over 4 plus 1 over 2x square root of 16 minus s squared plus c. And you can see that the integration of square root of 16 minus s squared is now what? 8 arc sine parenthesis x over 4 plus 1 over 2 x square root of 16 minus s squared plus c. So that is for the first format. That is how to integrate something like that. You can see, you can check through the note again. That is example 2. This is example 1. This is the step. Example 1, step 2, step 3. Let me zoom in a little bit so you can see. Just check through to know it's well explanatory, and yeah. So we move to another format. Yeah, that is example 3. We state that evaluate integral of, this is quotient format, integral of so we move to example 3. So example 3 state that what evaluate integral of a quotient function which is the x, that is the x over the square root of 3 plus x parentheses another parenthesis 3 minus x. So you can see the value at the denominator, or what is inside that square root is what is called difference of two square. Recall that 3, so let me just zoom in a little bit. Recall that parentheses 3 plus x and multiplied by parentheses 3 minus x is eventually what difference of two square, which is 9 minus x square. So instead of writing that, you can see in the next line that we are changing the expression to what integral of the x all over square root of 9 minus x square. So now relating again or comparing, making comparison, you can see that the integral of parentheses the x square root of 9 minus x square, comparing with integral of the x square root of integral of the x over square root of a square minus s square. So we can conclude that therefore a square is equal to 9 via comparison. So, and which means if a square is equal to 9, definitely it will be what 3. So thus, like we did in the first two example, we are still following the same step. So can then say let x is equal to what 3 sin theta, because you must determine a, that is the first thing. So after the determination of the a, then we can say let x is equal to a sin theta, which means x is equal to what 3 sin theta. So differentiating x with respect to theta, we can see that expression is now implies that what the x is equal to what 3 cos theta d theta, because differentiation of sin theta is what is cos theta, and if we want to integrate cos theta, we are going to get what sin theta back. So then you substitute. So substitution means what? Replacing x with anything that involves theta, the relationship between them. Shall you get now? And we've differentiated dx. Recall that our dx is what? 3 cos theta d theta. That is why you are saying the x is being changed to what? 3 cos theta d theta. And the one at the denominator, square root of 9 minus s square. You can see that what? You can see that the square root 9 minus s square is changing to what? Square root of 9 minus parentheses 3 sin theta all square. So in which we eventually have what? Integral parentheses 3 cos theta d theta all over square root of 9 minus 9 sin square theta, which implies that what 3 cos theta d theta all over, bringing out the 3 at the bringing out the 9 inside the square root of 9 minus 9 sin square theta, we eventually change to 3 because the square root of 9 is 3. So that is why you are having 3 square root of 1 minus sin square theta, which implies that was square root integral of, now 3 is cancelled 3. That is why you are having, that is why it was being implied that what integral of parentheses cos theta d theta all over square root of 1 minus sin square theta. And you have been acquainted with what? Acquainted with cos theta equals what? Square root of 1 minus sin square theta. So that is why you can see in the next line that, because I said here at the top, recall that cos theta, I've made mention of it, but for some people, I still make reference to it again. So recall that cos theta equals square root of 1 minus sin square theta, which means integral of parentheses cos theta d theta all over what? Square root of 1 minus sin square theta, which implies that what? Integral cos theta d theta cos all over cos theta, because square root of 1 minus sin square theta is what? Is cos theta. So which means cos cancelling out cos, you left with what? Integral of the theta, and you can easily integrate that one, which is integration of the theta is what? Is theta. That is why you can see that the next line is what? Theta plus x. So you can see that it's now theta plus x. But that is not the final solution, because you must change the theta back to what? Back to sine, back to x. So I recall that x is equal to what? 3 sine theta. So making theta the subject of the formula, theta will be equal to what? Arc sine parentheses 3 over x over 3. X is what? X is equal to theta is equal to what? Arc sine, because we are replacing theta with now x. So and recall the relationship between them is x is equal to 3 sine theta, and making theta the subject of the formula, we have theta is equal to what? Arc sine parentheses x over 3. So thus The integration of the theta, which is equal to theta plus c, we now change to what? We now change to arc sine parenthesis 3 over 3 plus c. That is the final answer. That is the answer for that what? For that integration. And you can see this one is, this example is related to the first second example. So I won't explain it at all. I will just skip through the slide. Just skip through it. You can see just comparing, making, replacing, substituting, and then see. Let me just make it slow a little bit. See. So you see, let x, so it's just the same principle. Can easily solve this. Yeah. So we go to example 5. So example 5 states that evaluate. It's just same example with example 3, but this one same little bit complex, though not complex though. So says that we evaluate integral of 1 all over square root of 25 minus 4x squared dx. So how can you solve this? The first thing is what? Determine your a. So how can we determine our a from here? Because you can see that this one is different from the initial format, but you can make it realistic. You can compare with the, by what? By applying factorization method. So if you want to factorize out 4, that is, if you want to eliminate that 4, let's say factorize that 4, that is the coefficient of s squared. So bringing it out, we make the expression of what? Integral of 1 over square root of 25 minus 4s squared dx implies that what? Integral of what? Parenthesis 1 over square root of 4 parenthesis. Recall, let me repeat myself. Integral of parenthesis 1 over square root of 4 parenthesis 25 over 4 minus s squared dx. So if you multiply back that 4, you still get the expression as square root of 25 minus 4 squared. So there's no magic there. So it's actually true. So which means the integral of parenthesis 1 over, you can see that 4 inside that square root change to 2 when it's coming outside. Why? Because square root of 4 is what? Is 2. So that's why we are now having what? Integral parenthesis 1 over 2 square root of what? Square root of 25 over 4 minus s squared dx. So bringing out that 2, because 2 is at the denominator, you can also say is 1 over 2. So that's why the expression is being implied as what? 1 over 2 integral of parenthesis 1 over square root of 25 over 4 minus s squared dx. So now we can now deduce that our a squared is what? 25 over 4. Comparing, making the same comparison now. So which means a is what? Is 5 minus 2. So let x equals 5 minus 2 sin theta. Normal protocol, normal procedure, normal process, normal steps. So again now, that is, now we are now using step 1 now. So see, so now doing that, definitely you differentiate. So the x is now what? 5 over 2 cos theta d theta. So the next thing is what? Substitution. So substituting x with whatever you want to do that is have relationship with that exact value. So I recall that we are having 1 over 2 integral of parenthesis 1 all over square root of 25 over 4 minus s squared dx. For which implies that 1 over 2, we are replacing it with theta now. Integral of parenthesis 1 over square root of 25 minus 4 minus parenthesis 5 over 2 sin theta all square multiplied by what? You can see that dx is now changing to 5 over 2 cos theta d theta. That is substitution for you. So now let me zoom this little bit. So which implies that 1 over 2 integral of parenthesis 1 over square root of 25 over 4 minus 25 over 4 sin square theta multiplied by 5 over 2 cos theta d theta. Which implies that, so if you factorize that 25 over 4, eventually I'm bringing it out of that square root. That's why we see that the implied line is that what? 1 over 2 integral of parenthesis 5 over 2 cos theta all over 5 over 2 square root of 1 minus sin square theta. You can see it. Let me zoom it. This is what I'm saying. Do you see it? Yeah. So you can see. So now In the next line now, we now have what? You can see that bringing out the square, you can see that this one is now can now cancel each other. That is 1 over 2 integral of parenthesis 5 over 2 cos theta all over 5 over 2 square root of 1 minus sin square theta d theta. So 5 over 2 cancel out 5 over 2. So that's why we are left with, in the next line we have 1 over 2 integral of what? Integral of parenthesis cos theta d theta all over square root of 1 minus sin square theta. And recall, just the same thing. Cos theta will always be equal to what? Square root of 1 minus sin square theta. Thus, 1 over 2 integral of cos theta all over just tautology actually. So the actual expression is now what? After replacing cos theta with square root of 1 minus sin square theta, we are left with what? You now have 1 over 2 integral of cos theta all over cos theta d theta, which eventually give 1 over 2 integral of d theta. So having this, that means the expression will now what? 1 over 2 theta plus c. So recall that x is equal to what? 5 over 2 sin theta. So we return everything back to x. So which means theta is equal to arc sine parenthesis 2 over 5x. So having that, 1 over 2 theta plus c, which implies that 1 over 2 arc sine 2x over 5 plus c. So thus, the integration of 1 over square root of 25 minus 4x squared dx is now what? Is now 1 over 2 arc sine parenthesis 2 over 5x plus c, and which is the final answer. So with these 5 examples given, I believe any question relating to this kind of illustration may call the example or question solved in this video, you should be able to tackle it. You should be able to solve it, because that is just the format. That is just the basic. So any question regarding this, supposed to be able to what? To solve it. So let me just recap myself. Let me just summarize everything. So if you are given in two format, for you to use sine theta trigonometric substitution method, because this one, let's just say you are using sine theta trigonometric method. So because the next one is to be on time, and the third video of this example will be on sec. So we are working on sine now. So when can you determine to use sine? That is when your integral question given is form of what? Square root of a square minus s square, or is a form of quotient function, that is 1 over square root of a square minus s square. So that is when you apply the what? You replace with it. You replace x with what? A sine theta. Show you again now. So this is example 1. This is all about example 1. Let me just zoom in. Example 1, let me make it a little bigger. So this is example 1. You get it now. And this is example 2. Example 1 is a little bit simpler compared to example 2. And you see, same process, same principle, same step. And this is example 3, which is the quotient function now. You see it. That one is a little bit simple comparing to just ordinary expression. So this is example 4, similar to example 1 and 2. And this is the last example here, example 5. Example 4. This is the solution. This is the steps. And the last example for this topic is example 5 and C. So I believe you understand this explanation and what you've done so far in this video. See you next time. Wish you best of luck. Believe me sincerely, following this process, you'll find integration topic lovely, and you get it now. So see you in the next class. Please don't just watch the video alone. Try to subscribe for you to see another video that will be dropped any other day, and try to like my video. Thank you so much. Always appreciate you guys.